Let A be the 2 by 3 matrix 0, 1, minus 1, minus a half, 0, a half. B be the column vector 3, 0, 5. C be the row vector 1, minus 1, 1. And D be the 2 by 2 matrix 10, 0, 5, 2.5. Also, let I be the 3 by 3 identity. For each of the following, state if the operation is defined and calculate the result if it is defined. And there's 8 operations to consider. And in there's a few multiplications, a transpose or two, and a couple of additions as well. So I need to know how to do all of those operations. So let me look it up and write down something to help me remember how to do matrix multiplication. Alright, so, well, my thing that I've got here about matrix multiplication is in terms of matrices A and B, but I've already got a matrix A and B, so I might just change the letters to E and F so I don't get confused. So, note, if E is M by N and F is R by S, then EF is defined when N equals R and EF is M by S. Excellent. Now I always remember this as the middle two have to be the same. So this has to be the same as this. And the answer comes out to be the outside two. Like that. So the middle two, N and R, have to be the same. N and R have to be the same. And the answer comes out as the outside ones, M and S. Excellent. Now, I also find it nice to draw a picture of this because often you're just presented with the matrices straight up and it will help you figure out if you've got it right. So, E is an M by N matrix, so M is the number of rows and N is the number of columns, and F is an R by S matrix, R by S, and R actually has to be the same as N, like that, and the answer comes out to the matrix EF, which is M by S, like that. Okay, so that's matrix multiplication. What about addition? So also, let's see, E plus F is defined if E and F are the same size and E plus F is the same size as E and F. And of course all of these are because of the way that you do the multiplication, but this is enough for the moment because I'm only going to decide which ones are possible first and then I'll do them afterwards. So let me start a new page and I'll actually try the questions. So A was BA. That's what I had to multiply. So in order to find out whether BA is possible, I need to write down the sizes of B and A. So B, if we go back and have a look, B, just here, was a 3 by 1 matrix. So B is 3 by 1. A, whoops, sorry about that. B is 3 by 1. A, let's go have a look at A. A is 2 by 3. Alright, so A is 2 by 3. And in order for the multiplication to work, I need these two numbers to be the same, which they're not. So BA is undefined. Alright, let's do B now. So B, I had to do A times B. So A is 2 by 3 and B is 3 by 1. So let's see this time. Yep, two middle numbers are the same this time. So AB is defined. Well, it says to calculate them if they're defined, so let's calculate it. A was the matrix, so AB was 0, 1, minus 1, a half, 0, sorry, minus a half, 0, a half, and B was 3, 0, 5. And we can check, having drawn our matrix, if it's the right size as well, because the rows in A ought to be the same length as the columns in B, which they are. Okay, so let's do the multiplication. So in order to do the multiplication, we combine the rows of A with the columns of B. And we know what size the new matrix is going to be. It's going to be 2, because that's the size of A on the left-hand side here, by 1. Like that. It's going to be that big. But I'm going to leave myself a bit more space for calculation. So I'll rub out that side there. So in order to do this, we go along each row of A and down each column of B. So let's have a look. 0 times 3 would be 0. 1 times 0 would be 0. And minus 1 times 5 would be minus 5. So in this first position, in row 1 and column 1 of the answer, I used row 1 of A and column 1 of B, and I put that in the first position. The second position will come out like this. Minus a half times 3, which would be minus 3 halves. 0 times 0, which would be 0. A half times 5, which would be 5 halves. And that's what goes in this position. And I've run out of rows and columns to combine, so I stop. And so my answer will come out to 0 plus minus 5, which is minus 5. Minus 3 halves plus 0 plus 5 halves. So 5 halves minus 3 halves, which would even be 2 halves, which would be 1. So my answer is the column vector minus 5, 1. Okay. So let's move on to the next one. So C, I was supposed to calculate A transpose D. So A transpose. So what size is A transpose? Well, how do we make A transpose? Well, A transpose is the same as A, only instead of having everything as rows, it has everything as columns. So the first row of A becomes the first column of A transpose, and the second row of A becomes the second column of A transpose, and vice versa. And so if A is 2 by 3, it's got 2 columns and 2 rows and 3 columns. A transpose must be the other way around. It must be 3 by 2. And D, let's go have a look at D. D was 2 by 2. Okay, so D is 2 by 2. Okay, so A transpose D, let's just have a look. A transpose D, the two middle numbers are the same, is defined. So let's calculate it, but I will need to start a new page in order to do that. So, I want to calculate A transpose D. So, A was 0, 1, minus 1. Minus a half, 0, a half, and they were the rows, so A transpose has those as columns instead. So the first row of A becomes the first column of A transpose, and the second row of A becomes the second column of A transpose. So that's A transpose, and D was 10, 0, 5, 2.5. So let's just check with our shapes again. The length of the row in the first one ought to be the same as the length of the column in the second one, which it is, so it works. So let's actually calculate it. So we need to do all the combinations of rows and columns. So row 1 and column 1. So row 1 will be 0 times 10 minus a half times 5. So that will be minus 2.5. I'm using decimals because one of them has a decimal, so I'll follow along with the same rules. In general, I would use fractions because that's tradition for most of mathematics, but since this one's got a decimal in D, I'll use decimals for my answers. Okay, so row 1 of A transpose and column 1 of D goes in row 1 position 1 of the answer. And so now I would move on to row 1, column 2. So 0 times 0 is 0, minus a half times 2.5 would be minus 1.25. Okay, and now I would move on to the second row of A transpose and back to the first column. So 1 times 10 is 10. And 0 times 5 is 0, so we get 10. And then I would move on to the second column. So 1 times 0 is 0, 0 times 2.5 is 0. And now I've finished all the columns of D, so I move on to the next row of A transpose and back to the first column of D. So minus 1 times 10 is minus 10. Half times 5 is 2.5, so minus 10 plus 2.5 would be minus 7.5. And finally, I move through the columns of D, so minus 1 times 0 is 0, a half times 2.5 would be positive 1.25. So there's my answer. So, next on the list is E. E, I have to do, let me just check. E, I have to do B times C. So, B was a column vector, 3 by 1. C was a row vector 1 by 3, So BC is defined because the middle two numbers are both 1 and they match, so the multiplication is defined. So let's see, BC is equal to 305, 1 minus 1, 1. And the answer is going to come out to a 3 by 3 matrix because we have 3 here and 3 here, and that's what the answer is going to come out as. So let's give ourselves space. So same as before, let's do our rows and columns. So row 1 of BC is just that single number, and row 1 of B, column 1 of C is there. So 3 times 1 is 3. And then I move on to the next column of C. 3 times minus 1 is minus 3. And then 3 times 1 is 1. And then I move on to the next row of B and back to the first column of C. So 0 times 1 is 0. 0 times minus 1 is 0. 0 times 1 is 0. And then I move on to the next row of B and back to the first column of C. So 5 times 1 is 5. 5 times minus 1 is minus 5. And 5 times 1 is 5. And that's my answer. Right, let's start another new page. E. Oh, we just did E, sorry. F. And F was CB. So we need to know C is, well, that was 3 by 1. And B was 1 by 3. So let's just check. Do our middle numbers match? Yes, they do. So this one is defined. So CB is defined. So let's calculate it. So CB would be equal to 1 minus 1, 1, 305. And my answer is going to be, oops, sorry about that. C is 1 by 3. Let's just go back and do all that again. Let's go right back to the beginning and have a look. C is 1 by 3. It's a row vector. So C is 1 by 3. And B is 3 by 1. So it still is defined because 3 is the same as 3. The middle ones match. So CB is defined. So let's calculate what CB is. CB equals, and I've done it all properly now, 1 minus 1, 1, 305. It was writing down the actual multiplication that told me that my first line was wrong with the sizes. So my answer is going to be 1 by 1. It's just a number. And as usual, I will do the first row of C, but there's only one row of C, and the first column of B, but there's only one column of B. So that will be 1 times 3, which is 3, minus 1 times 0, which is 0, and 1 times 5, which is 5. So I'll get 3 plus 0 plus 5, which is 8. Alright, so the next one would be G. So G was B plus C. So let's just have a look at the sizes of B and C again. B is 3 by 1. C is 1 by 3. And for addition, they have to be the same size, which they're not. This is 3 by 1 and this is 1 by 3. They're different sizes, so they can't be added. So B plus C is undefined. Alright, and that just leaves H, our last one, which is made of a whole lot of different parts. What is it? B transpose plus C, BC plus I. So let's just figure out all of the wheres and hows of whether that's possible. So first we'll need to have a look to see if B transpose plus C is possible. So B transpose is, well, B is a column vector. Its transpose would be the same, but row vector, so it would be 1 by 3. And C is 1 by 3. So the addition is certainly defined. Okay, so let's do the other part. BC we've already calculated. BC is certainly defined because we've already calculated what it is. And BC was a 3 by 3 vector. The matrix, BC is 3 by 3. I, at the very beginning, was said to be the 3 by 3 identity, so I is 3 by 3. So BC plus I is defined. And finally, we need to do the multiplication. So let's see. B transpose plus C would be the same size as both B transpose and C, so it's 1 by 3 as well. And BC plus I is 3 by 3. So certainly, let's just check, do the middle numbers match? 3, 3, yes they do. So B transpose plus C times BC plus I is defined. So we'll have to calculate it. So on one more new page, let's find those two bits separately. So B transpose plus C. B was a column vector, B transpose would now be a row vector. 1 minus 1, 1. And when you add matrices, you just add all the matching entries. So that would be 3 plus 1, which is 4, 0 plus minus 1, which is minus 1, 5 plus 1, which is 6. Okay. BC plus I. Now, BC from the previous page was this. And I, now the identity matrix, it was a 3 by 3 identity, and the identity matrix has 1s on the diagonal and 0s everywhere else. Okay, so when I add them, I add the matching entries. So, let me just make that a bit clearer by drawing some circles. 3 plus 1 is 4. Minus 3 plus 0 is minus 3. 3 plus 0 is 3. And I'd continue in that way. So 0 plus 0 is 0. 0 plus 1 is 1. 0 plus 0 is 0. 5 plus 0 is 5. Minus 5 plus 0 is minus 5. 5 plus 1 is 6. So now I just have to do the final matrix multiplication. B transpose plus C times BC plus I is equal to 4 minus 1, 6. 4 minus 3, 3, 0, 1, 0, 5, minus 5, 6. And the answer is going to be 1 by 3. And as usual, we'll follow down the rows. We will do the rows of the first matrix, and it's only got one row, and the columns of the second matrix. So 4 minus 1 is 6 times 405, sorry. So 4 times 4 is 16, minus 1 times 0 is 0, 6 times 5 is 30, so 16 plus 30 would be 46. And then we continue to move along the columns of our next matrix. Let's just make that a bit bigger. So 4 times minus 3 would be minus 12. Minus 1 times 1 would be minus 1. And 6 times minus 5 would be minus 30. So we have minus 12, minus 1, minus 30, which would be minus 43. And then we move along to the next column. And that would be 4 times 3 is 12. Minus 1 times 0 is 0. 6 times 6 is 36. And 12 plus 36 would be 48. And then after that, we would move down to the next row of the first one, but there isn't a next row. And so that's our final answer.